Hello everyone. In this video, we are going to take a look at some of the tools I've developed for Celestia. Those tools are available at this address. At the moment, the tools mostly focus on geometry preparation and virtual textures. The tools in general work across the platform except the Windows-only version of this single tool, but we will talk more about the details later. Before we talk about the tools, I want to mention something here. If you go to the very first release, I also uploaded a bunch of useful resources, including the installation files for Celestia, because the official website can have broken links, and I think it's advisable to have another place where things are accessible. This will be continuously updated when more resources are discovered, and I will just share it here. Now, for the distribution of the Celestia tools I have here, if you go to the release page, you can just download it from the zip file. I'm just going to save it to my local folder. For the tools we have here, I've built them for the Windows platform. But as mentioned, you can build those first three using .NET yourself if you know the build process. But we can talk more about that in a separate video. After you download everything, we can unzip it to get the result. So after unzip it, you can see that are the tools. If you sort by type, you can see there are 4 tools. Ignore create dump, then those 4 are the tools that is provided. You can open in terminal, and then we are going to invoke the tools mostly from the terminal. Most of the tools comes with a help command. So Celestia, if we do CelestiaCMODConverter, you don't know how to use it, you can do help. It will print you some of the typical patterns, but I'm going to go through each one of it. In this video, I'm going to focus mostly on how to use each one rather than the technical details of those tools. For specific things like star database and CMOD, we will talk much more in the file format in dedicated videos, and for virtual texture, I already uploaded some videos on that. So let's take a look at the star database first. The star database is referring specifically to a file that comes with your Celestia installation. So if you go to your Celestia installation, and if you go to config, you can see there is the first database file, right? And that one is inside data stars data. This is a binary file. It is quite big, and the purpose of the first tool is to convert that to a human readable format so you can inspect what is going on inside. To use it, it's fairly straightforward. You can do CelestiaStarDatabaseConverter, do a help to inspect the available commands. Here I'm going to show you how to use the first and the third command. So what we can do is do print and then drag this inside. And then, because it's not very advisable to print it directly on the command line, because it's too many lines, I'm just going to output it to output.txt file. And here it's going to output it. So I opened my tools inside the inner folder, so the output is going to be here. And if you open this one, you can see it prints all the star definitions using lines. There's another way you can output it into a more formatted version, so it's easier to parse in other programs that you might write. You can do a to YAML, and then it's the same thing, put in the file path and your output path. So in this case, it's going to be output.yaml, and it's going to parse it again, and we will get the output result. So here you can see output.yaml. If we open it, it's the same thing, just in a slightly different format. So that is how you can use the first tool. The second tool is CMODConverter. CMODConverter allows you to convert any generic 3D asset, including OBJ, FBX, 3DS, into CMOD file format. And it also allows you to convert between the ASCII version and the binary version of CMOD format. To use it, we are going to compare it with the CMOD view, which comes with Celestia. I'm just going to download this one here. So if we extract CMOD view, and that is the interface of CMOD view. To do anything with it, we need a model. So let me just use Blender to quickly create a model. I'm just going to use a Susan model. And I'm also going to assign a material so we can see some of the ways the two different programs handle material. So here I'm just call it my material, and I'm just going to randomly give it a texture so we can see how texture path is handled. Here I'm just going to use image I have. File, export. You can export to FBX as well, but I'm just going to use OBJ. Put it here, monkey. And we are done with Blender. Back in CMOD view, you can file, open. It supports the OBJ format, and you can see the file here. Now notice it provides a material editor, but so far I haven't been able to figure out how to use it. So, and then to save it, just do save as, and you can put it somewhere here. Say export from CMOD view, and that exports this CMOD file. The first way you can use CelestiaCMODConverter is to simply inspect existing files by using the inspect command. So if we do inspect, you can put in this guy here, and it prints the information inside this file. As you can see here, when you export it, the material information is lost. I mean, the texture information of the material is lost. So that is the behavior of CMOD view. You can also use this to inspect built-in models if you are interested. So for instance, this guy. Just drag it over here, and it's going to print to you similar information. So that is the inspect command. There is also the convert command. The convert command is very interesting. It supports quite a few different variations. So the first thing you can do is to simply convert from a 3D asset file to CMOD file. So I'm going to convert the monkey to the same path, but CMOD. And then you need to specify whether you want an ASCII version or the binary version. You can optionally also apply a scale. So here I'm just going to do a ASCII. Actually, I'm going to give it a suffix. And then I'm going to, oh, probably I forgot something. I need to do a convert. And then I'm going to do a binary. So you have the two files. Let me now inspect it. We can do inspect, and we can inspect the one we have just exported, the ASCII version first. As you can see here, the behavior of CMOD convert will export both material defined on the file. Because if you look at the OBJ file, the material definition, you can see it actually export. Actually, it's actually interesting. It only exports a single material. I don't know where the other one comes from. This is something probably we need to trim in the future. But it does export the correct material for this guy. As you can see, the mesh is referencing material index 1. You can also inspect the binary version. It should produce similar result. So that produces a similar result, right? So that is the first way you can do it. The second way you can work with it, because at the moment we do not support direct editing of those textures. So it's helpful to export an ASCII first, and then you can rename the path to whatever you want. So let's say monkey.png and save it. And then I am going to do convert. In this time, instead of converting from OBJ, I'm just converting from the ASCII to the binary version. I'm going to give it a number to differentiate. And then now if we inspect the binary version too, you can see CMOD to bin2 CMOD file. Oh, sorry. So the previous command had an issue. It's called CMOD. And then now if we inspect this one, you can see the texture name has been changed. As a side note, something I forgot to mention, when you are converting from OBJ to CMOD, it will automatically trim the file path if it is using some kind of absolute path. It will only keep the file name, because when you are loading the models in Celestia, it's going to ignore the path anyway, and because all the textures are always going to be loaded from the textures subfolder. That is everything you need to know about the CMOD converter. The next tool we're going to look at is called the virtual texture reference set. This is a very interesting one. So if we do virtual texture reference set help, you can see mostly you are going to use this single command, but this single command has two different variations you can use. The first way you can use it is to do simply find an output folder, and then you can specify the tile size. This is the physical size of the tile in pixels, for instance 512 by 512. That's the default one, and the tiles are always going to be square. And then you can say specify the levels, how many levels you want to output. We will see what it means later. For now, I'm not going to use the source. If you just specify 3 levels and press enter, it's going to dump those images into those folders, and also 2 very handy templates. So if we go here, you can see, let me just delete everything related to the 3D stuff and the output. Okay, you can see we have those 3 outputs. The first one is the virtual texture, and as the reference set goes, it gives you the reference set of virtual texture. Another file is the virtual texture definition file, which references the corresponding folder. And for the tile size, this one, remember, it's a display size threshold, right? It's just using the tile size for now and the corresponding image format. And for the SSC file, it's giving you a alt surface definition automatically. You just need to change this one and everything will work. That is the reference set generation. You can also put in a source file. So in this case, I have downloaded the blue marble from NASA. You can pass this guy in and specify the number of levels. So in this case, if I do this one, it's going to load this file and generate everything here. Now, if you look at it, it's going to be the sliced results of the source image. So that is a virtual texture reference set program. The next one is very interesting, and we don't need the command line anymore. It's a GUI application called Preview Picker. A Preview Picker is very interesting because when you are dumping the high resolution levels for your virtual texture set, you do not need to always output the complete level. Because for instance, if I want to do a level 4, it's going to have 4 times 128 items, right? You can just selectively output whatever detail you actually need. To demonstrate this concept, if we look inside Celestia, here I already have the reference set up. And right now we are looking at level 2. If we go inside, we go to level 3. So what you can do is, for the level 3, you don't need the entire complete coverage. So I'm just going to delete everything and keep only 4. So here I have the level 3. I'm just going to delete level 4 as well to make it things clear. If you go to level 3, I'm going to find tx_44, which is right here, and then select everything else and delete it. Now if we rerun Celestia, you can see that when a higher level is available, Celestia is going to use it. When a higher level is not available, it's just going to show the lower level. That way, you can selectively only output high level for the particular region you are interested in. And that is what the picker tool is designed for. If we open the picker tool, which is right here, there are a few features that comes with it, although there's no GUI. So you can double click to open a file. Here I have the blue marble, so I'm just going to open the blue marble. When you open it, you can see it immediately splits the image at level 0. You can use mouse wheel to zoom in, or not zoom in, but increase the level. Here you can see we're at level 4, level 5, level 6, level 7, 8, 9, 11, 12, right? So you can go to a different level and then see the coordinate for each level. By the way, the background is dimmed. You can change it to make it brighter by using the plus and minus key on your number pad or keyboard. Yeah, so after you have identified at which level, which tile you want to export, for instance, this case, you are interested in this one, then you can export only this specific region. You can zoom in by holding Control and then using your middle mouse button. So if you right-click on the tile, it's going to just export this single one, and it's going to tell you it's level 4. So you go to Outputs, go to level 4, and then remove this one, because the convention requires you to just do tx_x_y and then do save. It's going to take a bit to save it. The only problem with this program right now is it consumes a lot of memory, especially for large images. But as a handy tool, that saves you from having to do things manually. That way, if you go to example, you can see level 4 we have only a single image, and it's generated at a default resolution 512 by 512. So that is all the 4 tools, and wish you like it, and thank you for watching.